I'm sure you've heard the news. The year is 2004, a year that would be etched into the annals of history for a catastrophic event that unfolded on a seemingly ordinary day. A seemingly ordinary day on the coast of the Indian Ocean. The sun was shining, the waves were gentle, and people were enjoying the tranquility of the beach, unaware of the impending disaster. Suddenly, the ground trembles with unimaginable force. The earth beneath their feet shakes violently, sending shockwaves through the region. An earthquake, a monstrous tremor deep beneath the ocean floor, has awakened. The tectonic plates shift dramatically, releasing an immense amount of energy. It unleashes a force more powerful than any weapon. A tsunami. This colossal wave begins its journey across the ocean, gaining momentum and strength. Imagine a wall of water, taller than a 10-story building, rushing towards the shore. The sheer size and speed of this wave are beyond comprehension. It moves with a speed that defies belief, swallowing everything in its path. Buildings, trees, and vehicles are no match for its relentless power. The air is filled with the roar of the wave, a deafening symphony of destruction. The sound is a terrifying reminder of nature's raw power. This, my friends, is the raw, untamed power of a tsunami. It is a force that can reshape landscapes and alter lives in an instant. The 2004 Indian Ocean tsunami was a stark reminder of nature's awe-inspiring force. It struck with little warning, leaving devastation in its wake. It left behind a trail of devastation, forever etching itself into our collective memory. Entire communities were wiped out, and the landscape was forever changed. But what are these monstrous waves? How do they form? Tsunamis are typically triggered by underwater earthquakes, volcanic eruptions, or landslides. And what can we do to prepare for their devastating arrival? Early warning systems, emergency drills, and community preparedness are crucial in mitigating the impact of these natural disasters. Don't forget to subscribe to Space Fact Fusion for more amazing content on natural phenomena. The word tsunami comes from Japanese, meaning harbor wave. This term is quite descriptive, as it captures the essence of these powerful natural phenomena that often strike coastal areas with little warning. It's a fitting name, as these waves often target the vulnerable communities that hug the coastline. These areas, with their picturesque settings and serene environments, are often the most at risk when a tsunami strikes. But tsunamis are not just big waves. They are fundamentally different from the waves we see crashing on the beach every day. While beach waves are generated by the wind, tsunamis are born from the Earth's most violent and dramatic movements. Regular waves are driven by wind, their energy limited to the surface of the water. These waves are familiar to us, seen during a day at the beach, gently rolling in and out. Tsunamis, on the other hand, are born from powerful geological events that displace vast amounts of water. These events can be sudden and catastrophic, such as underwater earthquakes, volcanic eruptions, or even massive landslides. Imagine an earthquake, a volcanic eruption, or even a giant landslide. These are the forces that give birth to these monstrous waves. The energy released by these events is transferred to the water, creating waves that can travel across entire ocean basins. Unlike their wind-driven cousins, tsunamis involve the entire water column, from the ocean surface to the sea floor. This means that the energy of a tsunami is distributed throughout the depth of the ocean, making it far more powerful and destructive. This immense volume of water, traveling at incredible speeds, carries with it an energy that is difficult to comprehend. When a tsunami reaches the shore, it can cause widespread devastation, sweeping away everything in its path and altering the landscape forever. The aftermath of a tsunami is often heartbreaking, with communities left to rebuild from the ground up. Understanding the science behind these waves is crucial for improving early warning systems and mitigating their impact on vulnerable populations. The most common culprit behind tsunamis is earthquakes. Our planet's tectonic plates, constantly shifting and grinding against each other, can unleash unimaginable energy in an instant. When this happens underwater, the seafloor jolts, displacing massive amounts of water and setting in motion a chain reaction that culminates in a tsunami. But earthquakes are not the only culprits. Volcanoes, those fiery giants of the deep, can also spawn these destructive waves. Think of the 1883 Krakatoa eruption, where the volcano's explosive power unleashed a tsunami that devastated coastal communities. Landslides both above and below the ocean surface can also displace enough water to generate tsunamis. Imagine a mountain of rock collapsing into the sea. The force is staggering. And while rare, even asteroid impacts can trigger these catastrophic events. Let's picture the birth of a tsunami. Imagine an undersea earthquake, a sudden jolt that sends shock waves through the water. These waves radiate outward from the epicenter, traveling at incredible speeds, up to 500 miles per hour. What's fascinating is that in the deep ocean, these waves are barely noticeable. They have very long wavelengths, meaning the distance between crests can be hundreds of miles. But as they approach shallower coastal waters, something dramatic happens. The wave's energy, once spread out over a vast distance, becomes compressed. The wave slows down, but its height increases dramatically. This process, called wave shoaling, transforms the once unassuming wave into a towering wall of water. Section 5. From deep to shallow. As the tsunami wave approaches the shore, its behavior changes dramatically. The once gentle swell transforms into a raging torrent, its energy focused and amplified by the shallowing seafloor. The wave's crest, now towering above the coastline, crashes onto the shore with terrifying force. Unlike regular waves that break and recede, tsunamis inundate the land. They can travel miles inland, carrying with them debris, buildings, and everything else in their path. The sheer volume of water, often arriving in multiple waves, can reshape the coastline in a matter of minutes. Section 6. Advancements in detection. In the face of such a formidable force, early warning is our best defense. Thankfully, science has made remarkable strides in tsunami detection and warning systems. Today, a network of sophisticated sensors, buoys, and satellites work tirelessly to monitor the oceans for any signs of trouble. Deep ocean sensors, known as dart buoys, are strategically placed in seismically active zones. These buoys detect pressure changes on the ocean floor caused by passing tsunami waves. The data is relayed via satellite to warning centers around the world. On the surface, other buoys measure wave height, providing crucial real-time information about approaching tsunamis. Satellites orbiting high above monitor sea level changes, adding another layer of detection to our global warning system. Section 7. Nature's harsh reminders. The 2004 Indian Ocean tsunami, triggered by a magnitude 9.1 earthquake, serves as a stark reminder of the devastating power of these waves. Over 230,000 people lost their lives across 14 countries, making it one of the deadliest natural disasters in recorded history. In 2011, the Tohoku earthquake and tsunami struck Japan, causing widespread destruction and claiming over 15,000 lives. The tsunami, generated by a magnitude 9.0 earthquake, crippled the Fukushima Daiichi nuclear power plant, leading to a major nuclear disaster. These events, while tragic, have taught us invaluable lessons about the importance of preparedness, infrastructure resilience, and respecting the awesome power of nature. Section 8. Riding the wave of survival. When it comes to tsunamis, knowledge is power. Understanding the warning signs and knowing how to react can mean the difference between life and death. So, what should you do if you find yourself in a tsunami-prone area? First, familiarize yourself with the natural warning signs. A strong earthquake, a rapid and unusual receding of the ocean, or a loud roar coming from the sea. These are all nature's way of telling you to seek higher ground immediately. Don't wait for official warnings. Every second counts. Move inland and uphill as quickly as possible. Remember, tsunamis can consist of multiple waves, and the subsequent waves can be even larger and more destructive than the first. Section 9. A legacy of destruction and resilience. Tsunamis leave behind a legacy of destruction that extends far beyond the immediate aftermath. The sheer power of these natural disasters can reshape entire coastlines, altering the geography and the lives of those who inhabit these regions. Coastal ecosystems, home to a rich tapestry of life, are often decimated. The intricate balance of these ecosystems is disrupted, leading to a cascade of effects that can impact the environment for years. Beaches that once teemed with life are left barren, and the vegetation that provided shelter and food for countless species is stripped away. Coral reefs, mangrove forests, and other vital habitats are ripped apart, leaving behind a scar on the landscape that can take decades to heal. These habitats are not just beautiful, they are crucial for the survival of many marine species. The destruction of coral reefs, for instance, means the loss of breeding grounds for fish and other marine life, which can have a ripple effect throughout the ocean ecosystem. The saltwater inundation contaminates freshwater sources and agricultural land, rendering them unusable for years to come. Farmers face the daunting task of restoring their fields, often having to wait for the salt to be naturally washed away by rain. This contamination can lead to food shortages and economic hardship for communities that rely on agriculture. Marine life too suffers the consequences. with countless creatures displaced, injured, or killed by the sheer force of the wave. The impact on marine biodiversity can be profound, with some species struggling to recover. The sight of dead fish washed ashore and injured marine animals is a stark reminder of the tsunami's reach and the fragility of life in the ocean. Yet, amidst the devastation, there is always hope. Nature has an incredible ability to recover and rebuild. In the aftermath of a tsunami, we often see the first signs of regrowth and renewal. Vegetation begins to sprout in the affected areas, symbolizing the resilience of life. Communities come together to rebuild, showing the strength and solidarity of the human spirit. Nature has an incredible ability to recover and rebuild. Mangrove forests start to regenerate, new coral growth appears, and coastal vegetation begins to recover. This natural resilience is a testament to the enduring power of life and the ability of ecosystems to heal themselves over time. And we, as humans, are learning to adapt and prepare for the inevitable. By constructing tsunami-proof buildings and engaging in community disaster preparedness training, we can reduce the impact of future tsunamis. These efforts are crucial in ensuring that communities are better equipped to handle the challenges posed by these natural disasters. By embracing scientific advancements, strengthening our infrastructure, and educating future generations, we can mitigate the risks and build a more resilient future. Scientists are continually researching the impacts of tsunamis to develop better warning systems and response strategies. Modern coastal infrastructure is designed to withstand the forces of nature, and educational programs teach children about the importance of preparedness. Tsunamis are a powerful reminder of the awe-inspiring and sometimes destructive forces that shape our planet. The sight of a massive wave approaching the shore is both terrifying and humbling, a reminder of the power of nature. Aerial views of the impact reveal the extent of the destruction, but also the potential for recovery and rebuilding. By understanding these forces, respecting their power and embracing preparedness, we can navigate the challenges and emerge stronger from the waves. Community emergency drills and the study of tsunamis help us to be better prepared for future events. Resilient coastal communities are a testament to our ability to adapt and thrive in the face of adversity. If you enjoyed this video, please like, comment, and share to help us spread the word about the science behind tsunamis. Don't forget to subscribe for more fascinating content.